In this video, we're going to discuss memory analysis with volatility, and it accompanies the module by the same name on Cypher. For those unfamiliar with Cypher, you can find it at Cypher, just cyfor.isis.poly.edu, cypher.isis.poly.edu. So basically, memory analysis is the study of computer memory, as opposed to sort of traditional forensics where you look at hard drives and try to recover data from hard drives. Computer memory, or in our case is RAM, actually shows you what's going on in a machine at a given time. So RAM contains the information you're currently working on, the files you currently have open, processes that are currently running, all this stuff that you're currently doing. It's kind of the present state of the machine. So if you can capture that memory and then study that, you can have a much better understanding of what was going on, or what is presently going on in a machine. So on a forensics investigation, for example, before you shut down the machine, you may want to take a memory capture so you can sort of preserve the state of what the user was doing at that time. And just to note, you should take that memory capture before you shut down the machine. RAM is volatile memory, so once that machine is shut down, volatile memory is not maintained or without power, so you lose that information. The data stored in RAM is gone once the power is shut off. So take the memory capture, then you can analyze it. We're not actually going to discuss how to make that memory capture here. We'll save that maybe for a different module. But what I've gone ahead and done is I've downloaded a memory capture that was taken off a machine that was infected with the Zeus exploit kit. That's this file right here. If you look at these slides for this module, you can find a link to download that on your own. And we're going to analyze it with Volatility. And Volatility is one of the premier memory analysis tools. It's free. It runs on Windows, Mac, Linux. It's written in Python, and all in all, it's just a pretty solid tool. And how it works essentially is it's a collection of plugins, and you specify that you want to run a plugin against a memory dump, and Volatility will go ahead and run that plugin, and it will extract specific information. So you may be looking for, say processes running on the machine at the time of the capture, or maybe open network connections, or something to do with the registry, or files, or anything like that really, or maybe some data stored at a specific location in memory. Anything like that, and Volatility likely has a plugin that you can use to extract that information. So what I'm going to do here, and it's going to be a pretty brief tutorial, is we're going to do a brief analysis of this memory image right here. And all we want to find really is we want to have enough information to suspect that there's something malicious going on this machine. So pretend, for example, that we didn't know it was infected with Zeus. How would we go about determining that there was suspicious activity on this machine? So personally, the first thing that would come to my mind would be, let's look if it's connected, if there's any open network connections. Let's look if that machine was communicating with any weird machines at various locations, because we can say then that it's likely infected if the machine has a connection to some random location in another country that we don't have a good explanation for. So to use Volatility, the command we're going to use on Kali, it's pre-installed on Kali, so we use the vol command for Volatility. Volatility is written in Python, so on a lot of machines you may have to run Python and specify that you're going to run vol.py, the Python file. But on Kali, where it's pre-installed, and it's pre-installed on a couple of the forensics machines, you just specify vol for the command. You'll then specify a -f for the file name that you're running this against, and we're going to run it against zeus.vmem, and then you'll specify the plugin to run. There's some other options you can use here. We're not really going to get into much. Like I said, I just want to introduce you to the tool, and then you can so you can sort of see what it can be used for. There is way more that can be done with Volatility. But if you use the vol-h, you can actually see everything you can do with this tool. It's got all the options and all the plugins you can run. Dump password hashes over here. Really it can do a whole lot of stuff against a memory dump. Here's all the options. But we're going to keep this pretty simple. So we're just going to use a couple plugins. Like I said, you'll specify the image name, and then the plugin we're going to use first is called Image Info, and that's a pretty basic plugin that just gives you some information about the memory dump. So say we don't know, what kind of machine this memory dump was taken from, or maybe when that machine was last used. So we can run this this plugin, and it will tell us, for example, that it's a Windows XP machine, possibly Service Pack 2 or 3, and that this is the most recent time on the machine when the image was taken. Once we know that, the next thing we would want to do, and like I said, what we're going to do is see if there's any network connections. Just to show you quickly, not really related to what we're doing, but one common plugin you would use would be PS list. That'll list all processes running on the machine at the time the capture was taken. It's also a good way to determine if there's anything suspicious going on, if you see any weirdly named processes or anything like that. It's a brief, quick analysis here just to look at it quickly. You don't see anything that stands out. You can tell that it was made in VMware, but nothing really stands out. So we're going to move on to what I think in this case is probably the easiest way to determine that there's something suspicious. Let's look for any sort of network connections. Let's see if this machine was talking to anyone else. So the first plugin we'll use for that is the connections plugin, which basically looks for any open connections on the machine at the time of capture. And you can tell that it didn't find anything, so kind of a dead end there. But what you can also do is use a plugin called ConScan, and that will look in other places in the memory image for any recently terminated connections. So maybe not something that's currently going on, but a connection that was going on a little while ago. And you can see that our machine, the local machine here, you see it was communicating with a machine at this IP. So, it could be totally benign. This IP could be Google, or it could be downloading some file. But what we can do, and I don't recommend you actually go to this IP directly. At one point it was malicious. But what we can do is then look up this IP, for example, in any sort of a variety of tools that will tell you the location of an IP, and you can sort of see if it's located in maybe a weird area that'd be of concern. So we can use this tool on iplegends.com, which looks up IPs and tells you the location. That's a geolocator. Basically, all you have to do is type in the IP here, and I've kind of already done that. And then you find it, and the tool is kind enough to tell us that this IP is located in Moldova. Nothing against anybody that lives in Moldova, but personally this would be a cause for concern of mine. Why is my machine, have a connection to a Moldovan, I guess that's how you say it, Moldovan IP? So that would be enough cause for concern for me to then say, okay, maybe we should do some further analysis on this machine. We're not going to do that in this tutorial. I'm actually going to leave you right here. But for those interested, this can be taken a whole lot further. You can use Volatility for much more analysis of this memory image. You can actually go ahead and find the malicious data on the machine, the malicious executable, and extract it, and maybe look for other indicators indicating that this is infected with Zeus. I have put in these slides, and I believe in the references, links to more complete walkthroughs that go through this memory dump. Much of this demo came from those walkthroughs, but those will take it a whole bunch more steps further. So you can go ahead and not just look at the network connection, but you can actually go and find the malicious executable, extract it, and then look for other indicators that this was infected with Zeus. But for a brief introduction to memory analysis and to Volatility, I think this should give you a good idea of how you can use Volatility to look at a memory image. And like I said, you can do way more with Volatility. There's a lot more plugins, and I highly recommend you check out that other walkthrough. But for now, that's really all we're going to cover here. So I hope this made some sense, and I hope you guys enjoyed, and hopefully you learned something. And like I said before, make sure you check out Cypher. All the material links are all available there. Again, Cypher, cyfor.isis.poly.edu. That's it. Thanks for listening.